this case, I'm going to make this an algebraic example with a numerical example integrated in one, plus 12ab. And so the big question over here is, let's factorize. Okay, and remember, we're only doing the first type of factorization right now. We're only looking at the golden rule. Before you do any type of factorization, always check for a common factor. And so far, that's the only one we've learned. Now, is there something you see in each of this? Now, this one looks very, very similar to the previous example because there's a squared, there's a, and there's ab. And that's exactly what we had previously. However, in this case, we've also got numbers in front of these variables, right? There's 3, there's 9, and there's 12. Now, if you look at 3, 9, and 12, you will tell me, Mud, 3, 9, and 12 are all multiples of 3. In other words, they are all numbers in which 3 can divide evenly into. So, again, I can say 3 is common because 3 can go into 3, 3 can go into 9, and 3 can go into 12. As well as A is common. Three is common, and so is A. So let's factorize this thing over here. And we're going to, if 3 is common and A is common, it means that we are going to take out, therefore, 3A is common. Right? And so let's remove that. Let's factorize it and let's see what happens. I'm going to continue with this thing over here, and I'm going to say that thing is equal to 3A, and then I open a bracket. And I say 3A times what will give me 3A squared. Well, I've already got 3A, I just need to multiply it by A. And there we go. 3A times A gives me 3A squared. Then we do the next one. This is a positive number multiplied by what? By what? What must go over here to get a negative? That's going to be a negative. Very good. 3 times what number must be multiplied to give me 9? That is 3. And I've already got an A, and I just want A. So 3 of 3 A's, in other words 3 times 3 cows, will give me 9 cows. And therefore I get A times minus 3 gives me 3A times minus 3 will give me negative 9A. So okay, again, a positive times what will give me a positive over here? A positive multiplied by a positive. Okay, a positive multiplied by a positive will give me that positive, and then I say 3 times what number will give me 12? 3 times what number will give me 12? And that is 3 times 4. I've already got 1A, I only need 1A, so I've already got it there, that's fine. And I need to multiply it by B. And that's done. So I'm going to take this expression and I'm going to check when I multiply it out, do I get exactly the same thing? So I'm going to do that on the next page. 3A, A minus 3 plus 4B. 3A, oops, A minus 3 plus 4B. Let's multiply that out. Okay, so that's going to be that times that, that times that, and that times that. Okay, my errors aren't great, but it is a work of art. Okay, 3A times A. Well, let's multiply the numbers. 3 times 1 is just 3. A times A is A squared. Positive times a negative is a negative. 3 times 3 is 9. And that leaves me with A. A positive times a positive gives me a positive. 3 times 4 is 12. And A times B is just AB. And so I've got 3 squared minus 9A plus 12AB. And that's exactly what I started out with. Remember, this was products. It was multiplying out products. And on this side over here, finding this thing over here means that we have factorized. Okay, so let's look at another example. Now this one's going to be quite interesting. This is a squared b cubed c squared minus ab squared c squared plus 2a cubed b squared and c to the power 4. Now, we have to look at the highest common factor here. A squared is not in everything because a squared is made up of a and another a, and over here we just have an a and there's a cubed. So if we look at this, we can say a is common. Just a is common, right? Then we look if we have b cubed, b squared, b squared. So this b cubed is actually b squared times b to the power of 1. Okay, so therefore b squared is common. Okay, and then thirdly, c to the power of 2, c to the power of 2, c to the power of 4. Now c to the power of 2 can go into c to the power of 2, c to the power of 2 can go into c to the power of 2, c to the power of 2 can go into c to the power of 4. But c to the power of 4 cannot go into any of the other c's. Similarly, b to the power of 3 cannot go into b to the power of 2, but b to the power of 2 can go into b to the power of 3. And that's how we know what's common. So in the last part over here, what we're going to do is we're going to say c to the power of 2 is common. Right. Okay, so what I've identified now that is common in each of those are essentially the things that I have to take out in order to factorize. And I'm going to put that over here equal to, it's going to be a b squared c squared multiplied by. So a times what will give me the a squared that I need over there? The answer is just a. The b squared times what will give me b cubed? It's just b. And c squared is already there, so I don't need to do anything with c squared. Then I can say, okay, a positive times what will give me this negative? That's a negative. A times what will give me a? It's multiplied by 1, but it's invisible 1, so I don't need to put it in. B squared times what will give me that? Now let's just look at this thing. A, b squared, c squared. That's identical to this entire thing. So this thing multiplied by 1 will give me that entire thing over there. So we're done with that. Okay. Then finally, let's look at the last one. This invisible 1, which is positive, times what will give me a positive? The answer is positive. And 1 times what will give me 2? The answer is 2. And I've got a, I need a cubed, so I need to add another a squared. I've got b squared, and b squared already there, so that's fine. And then I have c squared. How do I get c to the power of 4? I multiply by c to the power of 2. And the reason here is 2 plus 2 gives me 4. 2 plus 1 gives me the 3. And that's how you see it. Now you can confirm that this answer is correct by doing a check. And how do you do a check? Is you multiply it out. This times this times this, and that times that. Okay. So there we go. That's your next example.